Now capacitance. Here I want to show a simple theory that when the capacitance are connected in series, you see due to electron drift, that is electron electrons drift, that is same charges are developed in each capacitor, but in parallel connections different charges are developed in each capacitors, and both plates have same charge but of opposite sign. This I want to tell you. This is the most basic. In series you see the charge developed in each capacitor is the same. Mm. So now the question is, uh, find the charge appearing on each of the three capacitors given in the figure. Here you see the diagram. This is 8 microfarad, and now again you see this is 4 microfarad, and here 4 microfarad, and now this is connected to a 12-volt battery. This is connected to a 12-volt battery. Now we have to find out the charge in each capacitors. So let this point be A, B, C, D and E. This is capacitor A, this is capacitor B, and this is capacitor C. So 12 volt. Let Q charge be developed here, so this will be minus Q, and now Q1 charge here and minus Q1, and this will be Q minus Q1 and minus Q minus Q1 here. So this potential is 12 volt, but this potential is 0. So this all these potentials are 0 potentials. Now Q, this Q will be 8 microfarads, C into V, and V, that is VA, this is V because 12 volt, V minus VB, and Q1, this will be 4 microfarad, this VB minus VE, and since VE is 0, so we can take Q1 is equal to 4 microfarad VB. Now if we take these two equations, what I am going to do, I am going to multiply equation 2 by 3, equation 2 by 1. So 2 into Q1, this will be 8 microfarad VB. This is equation 3. Now if I add 1 plus 3, what I get? We get Q is equal to, here 8 minus 8 VB cancels out, so Q plus 2Q1, I get 8 microfarad into V. This is V is 12, Q plus 2Q1 is equal to 8 into 12. This is I get here. Now this be equation 4. Now let me see another, that is Q minus Q1 CV again. Here 4 this is 4 microfarad, 4 microfarad, 4 microfarad into VC minus VD. Here you see VD, it is 0 potential, so I have considered this as 0 potential, and so this Q minus Q1, 4 microfarad VC, this and this are in the same potential because they are joined, so they are in the same potential. So Q minus Q1 is equal to 4 microfarad into VB. Now what I am going to do is VB, the value of VB from equation 3, the value of VB, this is from equation 3, from equation 3, I get the value of VB, that is equal to 2Q1 by 8. Now when I put this value in equation 5, uh, now from equation 5, if I put this value, that is Q minus Q1 is equal to 4 into 2Q1 by 8, 2Q1 by 8, 8 means 8, so Q minus Q1 is equal to Q1, so Q is equal to 2Q1. I get 2 Q is equal to 2Q1. Now from equation 4 I get that, from equation 4 what I get is Q plus 2Q1 is equal to 8 into 12, so Q is 2Q1, so this becomes 4Q1 is equal to 8 into 12, so Q1 is equal to 24 microcoulomb. This becomes 24 microcoulomb. And now your I have got a relation now here Q, this will be equal to 2 into 24, that is 48 microcoulomb. And now here Q minus Q1, that is 48 minus 24, that is 24 microcoulomb. This is the charge in each capacitors which I have calculated it for you. So here I have considered this as V, that is 12 volt, and this as zero potential. So this is the value of charges in each capacitors. Now again, this is another circuit. We have to find the potential difference VA minus VB. This we have to find out. Say I have drawn the circuit here, Q minus Q1, Q minus Q, here Q1 minus Q1, and Q minus Q1 here, and these are in series, so the same charge will develop here. As I have told you earlier, this is in series, so same charge will develop here. Now this is in zero potential, and this is V, that is 12 volt. So here Q will be equal to 12 minus VC. This is so, and Q1, that will be equal to CV, again 4 VC minus VD. VD is your zero potential, so Q1 will equal 4 VC, and here again Q minus Q1, here, this will be how much? 4 yeah, this is VA, and since VB is your 0, so VA. Now I'm going to do something here. I'm going to that is uh, and here again Q minus Q1, that is here 2 VC minus VA, here VC minus VA. So what I am going to see, I have calculated the charge of every capacitor, because you know Q is equal to CV. This is the formula I have used. Now I am going to do something here. What I am going to do here, that I am going to multiply this equation by 2. If I multiply this equation by 2 Q minus Q1, that will be 4 VC minus VA. So 2Q minus 2Q1, that is 4 VC minus 4 VA. Now if I add this equation, let this be equation 1 and this equation be 2, if I add these two equation, then what I get? I get what do I get? If I add this to equation, 3q1 4vc, that means 4va is equal to this. So uh, minus this will be plus, and okay. So here I get this very equation. Let us stop it here itself. There is some calculation, nothing else. It can be easily calculated, only there is some calculation. Now I am going to do one thing. Here you see from this equation, q is equal to this this I am going to multiplying both side by 2, then it becomes 4 12 minus vc. So 2q is equal to 48 minus 4vc. Now your 4vc is how much? 4vc is q1. So 2q is equal to 48 minus q1. So 2q plus q1, this is equal to 48. Let this be equation 3. I keep it here itself. Now again I have to do something, that is what I'm going to do is if I add these two equations, then q will come out to be 4va minus va, the value of 4va. Acha. Now there is some, what can I do? Let me see. This is this much, this is this, and vd this is 0. So so now see capacitance, we have to find the potential difference va minus vb. So I have drawn this circuit. Now this here q1 and my q1 minus q1, and these two are in series, so same charge will be developed here, as I have told you earlier in the series connection. Now this is at V and this is at 0, so your Q will be 2 microfarad V minus Vc. So this I can do something, let it be here like this, and now again q1, that will be equal to 4 vc. Vd is your 0, this Vd is your 0, so it will be Vc. Now this be equation 1, this be equation 2, and again q minus q1, this is for here 2 Vc minus Va, this is your A point, Va. Let this be equation 3. First of all I can find out the equation, and now q minus q1, this is also 4, and that is Va minus Vb. This B point is 0, so I can take this as 0. This is the 0 potential. So here q minus q1 will be equal to how much? 4. This is 4, sorry, 4 4. This is 4 4 4 va. This is 4 va. This be equation 4. Now I am going to do something. First of all I am going to take this to equation, that is I multiply this by minus q. So if I multiply this by or I say 4 minus take 4 minus 2, I get 4 minus 2, q minus 2 q1 is equal to q minus 2 q1 for q minus 2 4 va minus 4 minus minus 4 vc, minus 4 vc, and this is equation 5. Now I am going to take this equation, oh no, this one third, from equation 3. Here again q minus q1, that is equal to 2 vc minus 2 va. This is equation 3. Now I am going to eliminate something for this. I'm going to eliminate something. If I'm going to multiply this by 1 and this by 2, what do I get? I get q minus 2q1 is equal to 4 va minus 4 vc, and this will be 2q minus 2q1. This will become, I'm writing this at first, minus 4 va and plus 4 vc. If I add this to equation, if I add this to equation, let this be 6 and this be 7. If I add this to equation, 6 plus 7, what do I get? I get here this 3q minus 4q1. This is equal to how much? This is 0. So I get a relation, that is 3q is equal to 4q1. So q1 will be equal to 3 by 4 q. This I got a relation. Let this be equation 8. Now from equation 1 I am going to do something, that is q is equal to 2 v minus 2 vc. As I know this is 4 vc, so I am going to multiply this by 2. 2q is equal to 4 v minus 4 vc, and the value of vc, this value of vc from 2 vc is q1. So 2q is equal to 4v minus q1. So 3 vc with q1. So what do I get? I get 2q plus q1 is equal to 4. V is your 12 into 12. So 2q, and q1 is 3 by 4q. This is equal to 48. So here I get this LCM is 4, 8 plus 3, 11. So 11q is equal to 48 into 4. So q comes out to be 48 into 4 by 11. This much micro coulomb charge, it comes out to be this much. So now your q1 is how much? Q1 is 3 by 4 q. So this will be, it comes out to be 3 by 4, 4 cancels out, 3 into 48 by 11. And here we know that q minus q1 is equal to, is q minus q1, that is va minus vb. This is v minus va. So q minus q1, q minus q1, let me do here q minus q1, that is q is your how much? Yes, 48 into 4 by 11 minus q1 is your how much? This is your q1 is 3 into 48 by 11. So this comes out to be how much? 11 is your LCM, 48 common. So 4 minus 3 is 1. So this comes out to be 48. If you this comes out to be 48. One thing, q minus q1 is equal to, I have not written this 4. This is cv, because your formula is q is equal to cv. So c is this, v is this. So I have not written this q minus q1, this is equal to 4 va minus vb. So this is how much? 4 comes here and va minus vb. So 4 12s are 12 by 11 volt. This is equal to va minus vb. This is your answer. This is q, this is microcoulomb because it's microfarad, and this is your answer. Capacitance, here I have taken this circuit to make you understand that what a capacitance does. What does a capacitance? What is the work of a capacitance? So here in this figure, it is kept closed. The switch is kept closed for a long time and then it is opened. When this switch is closed for a long time, uh, while when the capacitance is being charged, then there is a flow of current in the circuit. But when both the plates are equally charged, then when both the plates it becomes equally charged, then no more current flows through this through the capacitance. There no more current flow through this capacitance. When this it becomes fully charged, both the plates are fully charged with opposite sign, then no more current flows through this capacitance. Now so this here this up to this becomes cut off, only this circuit remains. So now the current flowing through this circuit will be um, V is equal to I and R 10 plus 10 because they are in series. So 20, V 12. So 12 by 20, that is equal to I. This comes out to be 4 3s are 12, 4 5s are 20. 3 by 5 ampere, 3 by 5 ampere current is flowing through it. 3 by 5 ampere is current flowing through it. That is 3 by 5, it comes out 0 0.6. This is 0 0.6 ampere current is flowing through it. Now what happens when the switch is off? When the switch is off, then now when switch is off, now what happens? See, when the switch is off, switch becomes off. Uh, Switch is off. Now no more current flows through this circuit. No more current flows through this circuit. This is 10 ohms. Now the discharging of the capacitance charge starts, and the discharging of the capacitance it starts. That means capacitance starts to discharge, and the current flows through this circuit. Now the current flow through this circuit. So here your that discharging, this is Q is equal to Q e to the power of minus T by C into R. So here this is, it is also I is equal to I naught E minus T by C into R. So here your I naught, that is here earlier, that is 0 0.6 ampere current was flowing through it, and E time it is for flow when the current in the middle resistor at t is equal to 1 millisecond, that is 1 into 10 to the power of minus 3 second, and C, this is the capacitance, 25 microfarad. So this will be 25 into 10 to the power of minus 6, and resistance is your 10 ohms, so this is 10. If we are going to calculate it, that is e to the power of minus uh, 10 to the power of minus 3 by 25 into 10 to the power of minus 5. So this will be 0 0.6 e to the power of minus 10 to the power of minus 3 plus 5 divided by 25. So this will be 0 0.6 e to the power of minus 10 to the power of 2 by 25. So this will be 0 0.6 e to the power of 100 minus 100 by 25. So this will be 0 0.6 e to the power of minus 4, and this comes out to be 0 0.6 by e to the power of 4. Now I will have to calculate this e to the power of 4 by the help of a calculator. 0. 0.6 into 1 by e to the power of 4. So 0.6 e to the power of 4 is 54.98, and when I divide it by this is equal to 0.6 into 0.01098. This means it comes out, there is uh, 1 minute. E to the power 54. No, sorry. E to the power 4. It is 54.59. 54.598. So here 1 divided by 54.598. This comes out to be this into zero point 0.6. So this will be 0.01098 ampere. If I multiply it by 1000, it will be 10.98 milliampere, or you can say 11 milliampere current. This is your answer. So why I have selected this problem to show you that what uh, what is an advantage of a capacitance. When this is closed, then the current flows through it, and when the capacitance is being charged, then there is a flow in the circuit. But when it becomes fully charged, that is fully charged, then no more current flows through this capacitance and the current flows only through this circuit. And from there I've found out the value of current, that is 0 0.6 amperes flowing through this circuit. Now when it is switched off, then there is no current flow in this circuit, and capacitance starts to discharge. And when it starts to discharge, then and this is the formula. And from where we can find out that we got that 11 milliampere current is flowing through this circuit. So this is your answer. Because this is ampere, 1 ampere, it will be equal to 1000 milliampere. So this is your answer.